introduction what the project is all about. First of all, this is not a lifetime experience, so it shouldn't take more than 2 or 3 weeks. Short project, okay, unless you make it really, really long yourself by adding things. So basically, what it is all about is to test that you have learned something during the course. First of all, it's a group assignment. So, well, group is from 1 to 3 students. Okay, and only one report is required. And it can be integrated with some other course. So if you at the same time attending some embedded engineering courses or some health technology courses or programming, any kind of programming courses, then you might actually thought about a topic that would, you know, support the both of those studies. So, but it's up to you. I have some examples also that could be only, you know, only for this course. But anyways, it can be integrated and should be integrated with other courses. There are some examples. If you have taken, for example, the virtual instrumentation. So LabVIEW environment has also tools for filtering. And basically to apply those filters on LabVIEW, you need to know the fundamentals of the filtering before you can do it effectively. Okay, so if you want to play with the LabVIEW, do a application based on that one, excellent. ARM processors, okay, you are using, how many of you are using ARM processors on some embedded engineering course? Okay, good. Yes, on any of those courses you can actually, oh, okay, there's even the course name is ARM processor and embedded operating systems, right? That's the Keijo Länsikunnas who is teaching those, right? Am I correct? More or less, good. Then, of course, the embedded systems programming course or smart systems and wireless communication. I think that's, let's see, that's the young guy. I never remember the names. Sami Sainio, yes, thank you. Sami's course. Sensors and advanced physics, okay, excellent topic. I think this is from Sakari Lukkarinen. Sakari is the person who sold some of these versions of MATLAB to former EVTech when I was buying those from Sakari. So Sakari was working for a company which was a distributor of MathWorks way back in, 10 years ago, something like that. So he more or less knows the same stuff from MATLAB as I do. And he's also a physicist. Okay, and any programming course. And you may propose your own topic. And okay, short, keep it short, meaning proof of concept. This is not a final product, but proof of concept. And yeah, there are some guidelines of the group reports, and we are following the formal format is the final year project thesis guidelines kind of thing, which has the first page is the title page, then there's the abstract. You don't need to worry about the finished abstract, only one abstract. But anyways, follow the guidelines how to make a report. This is also a nice exercise since you will be doing the final year project at some point. If you are exchange students, you might even then be doing the Metropolia final year project at some point. I can tell you later some possibilities. Okay, and then about the grading. This group will receive maximum 10 points times the number of people on that group. this is really evil way, since after finishing, for say, 3 people do a project and get only 8 points each on that group, and then 2 of those find, okay, that third one didn't even appear. So they can take, 10 points each and leave whatever is left for the third one. Okay. So that's how democracy works in workplace. It works. So if you are so-called the third member of the group, remember to contribute. Okay. And then, of course, if you are only one working on the group, you might actually kick the other ones out and say, okay, I will do it myself. Since otherwise those 2 would get the points which you earned. Okay, I know this is evil, but it works. Yeah, there are some topics I kind of took my old records, and all of these have been done. Well, not every one of these, since the Raspberry Pi is quite new, at least the version 3. Okay, but all of those had been done in some platforms. Acoustic radar can be done with the loudspeakers with, say, at least few watts of power and, say, decent amplitude response. So you need to have quite nice response of your loudspeakers. Any stereo loudspeaker would do. Play a sound that you can recognize and record that one with a microphone. If there is a reflection, you will actually hear it from a microphone. And that's how acoustic radar actually works. You send a pulse, kind of pulse, sound pulse, it bounces back, you record that one and distinguish which part is the original and which part is the reflected sound. And it works. And in a proof of concept level at least. Okay, second one, acoustic data transfer between computers using modulated transmission. Anyone who is really interested about the data transmission technology, this is your topic. You will learn a lot. So basically, this stuff is on the communication side. It's very simple. You just need to review the Telecom 1 or Telecom 101, the theoretical lectures, and then this is to apply those with the acoustic transmission channel. And yes, it can be done. It's a lot of fun. It makes funny noise. Okay, that's quite interesting actually. Acoustic tachometer to detect car engine RPM readings. So it's just by listening an engine, how many revolutions camshaft actually does. Well, because of those, you really will hear on engine the explosions. That's the most noisy part. Right. It's a combustion engine. It makes explosions on the camshaft. And based on that one, you can actually find the RPM readings. But you know, there's also belts and all kind of things, and it's very noisy environment. So it's not too straightforward, but it can be done. Okay, anyone playing guitar? Nobody? Oh, you are. Okay, if you want to test if you can make a guitar tuner with MATLAB or some other tool, yes, that's sure. Graphic equalizer. Are there anyone who knows what the graphic equalizer actually is? Except, of course, you do. Okay, that's a kind of multiple band tuner for, you can basically fix the amplitude response of a signal by narrow band filters. Okay, for example, there's this half-octave graphic equalizer, meaning a lot of bands. I think 31 bands on that one. Then there's the audio spectrum analyzer. There are also audio spectrum analyzers, a lot of those already say reference designs. So if you find a reference design, try to make your own. If you copy that one, I will notice and I will be really mad about it. Okay, then Raspberry Pi audio filter. We have some sets of the latest Raspberry Pi 3s. You install a some operating system there and make it to run. And there are also audio in, audio out. That's one. This is digital signal processing class. Okay, good. Welcome. Then, okay, then we have this Cypress Semiconductor Kits piece of programmable system on chip. So that's the audio, not audio. It has actually the analog to digital filter, the analog to digital converters. There are also analog filters. This has ARM7 core, so it also has some computing power. Okay. Then we also have the Cypress piece of force. Okay, same, a little bit more sophisticated hardware, but it has 8051 processor, lower scale processor. But you can do a lot of these, a lot of say things with these kind of systems on. Basically, these would be more or less like IoT things, what you do with this. Or some other platform. Favorite microcontroller, audio signal is easy. Or, okay, I also mentioned the data logger, how to make it actually a digital signal processing a kind of thingy. You'd start doing oversampling and then drop the sampling rate. You need a anti-aliasing filter there and also figure out how to give one sample out for every 10 samples in. Okay, and then some more. Okay, image processing. How many of you are interested about image processing? Not too many. Maybe. Okay, excellent. Same tools as in this audio or one-dimensional data processing. You also can use those in images. The tool sets are just called a little bit different, but yes, you can detect cloud movements, for example, from satellite imagery by using correlation technique, which also requires some filtering of the data. So to get rid of these, static artifacts and that kind of things. But on the proof of concept level, it works. OCR, how optical character recognition actually works. Yep. Well, easily. And again, proof of concept level. Then there are actually that middle one, white or blackboard picture improvement. Let's take a look at a one of these white the pictures. For example, well, that one. I'll take, for example, this picture. Maybe I'll take it. There. How to, for example, find the frame, this aluminum frame, how to find it. There are some tools to find it. How to make the lighting of this one even. So now it has darker on the edges and then bright on the middle. How to enhance colors. All of those filters, you can find it from the image processing toolbox what we have in the MATLAB. And also there are similar tools also on Octave. and that will go directly into use. I would use it definitely if it works well. Find a, say, algorithms to improve the quality of those pictures. Okay. Then a couple of kind of nice to know things. How to make video image stabilizer. So you have basically a video which basically is frames, frame, 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 and there's some space jitter between the frames. You just need to find how much is the jitter using some correlation technique maybe, and then just move those on the so that the most common features match from each other picture, and that's image stabilizer. Crude one, but it works. Sound sampler and player. Okay, that's actually a sound sampling is technology where you get, for example, a sound of an elephant and tune it into different tones, and then you can start playing elephant choir. So, Hakuma Tatata, or something like that. So, yes, and those are just examples of what I came up. If you have a better, please, just make your own project topic. Most important thing here is, okay, you will use some of the things what you learned here. Okay. Then there is also a proof of concept level project. Of course, if you feel like it, you can basically extend that one into innovation project or something like that, if you feel like it. But it's, for this course, proof of concept is enough. And the documentation, you need to practice the writing your thesis now. This is your 3rd or 4th year. Right, you need to practice, practice, practice. Okay. Any questions about the project? Yes. Yep. So is it all of them, or should we take one? Take one, for example. Well, let's take the first one. So how to make it proof of concept? You have a setup which works, which has a loudspeaker. All right, that's a loudspeaker. You run the signal to loudspeaker from MATLAB or Octave. You know how to make sounds, right? Then you also can record sounds quite easily from a microphone. Okay, so basically, if you get a reflection, for example, from a brick wall, any wall, you get a little bit of reflection, and you can detect that reflection and show it on a graph. Okay, I got that reflection exactly or close enough to that distance. That's proof of concept. Then you just report it. Yes, it works. If it doesn't work, you just have to try harder. Okay. And those audio things, they are, basically you could do some tone enhancement or filtering, a simple filtering, and just notice, okay, this is the original sound, and hear it, then you run it through that filter and say, oh, there's a change. And preferably the change that you were expecting. So that's called proof. Okay, any other questions? So pick one topic, tell me next week. Next week, Monday morning, way too early. We will start at 9. Tell me about your project, which one we will be doing. Okay, good. That's all for the project part. So you can now switch off the recording.